Faces. Today, we are going to discuss the relationship between two very well known quantities in classical mechanics and quantum mechanics. These are Poisson brackets and commutators. Now, Poisson brackets are a very central mathematical quantity in classical mechanics. Now, the Poisson brackets of two dynamical variables is very important for certain things. Poisson brackets are used for defining constants of motion and conservation laws and also canonical transformations. They are very important in canonical transformations. And commutators, on the other hand, are very central to the idea of the generalized uncertainty principle. We would talk about the generalized uncertainty principle and canonical transformations in a later video. But at this moment in time, it is enough to emphasize the impact of these two quantities in physics as a whole. Now, canonical transformations of two dynamical variables, that is to say, two variables defined in phase space, that is the space of the generalized coordinates and the generalized momenta, is this. We have two dynamical variables which depend upon the generalized coordinate and the generalized momentum. It is not to say that they cannot depend on other variables as well, but they should depend upon the generalized coordinates and the generalized momentum. It is defined in this fashion over here, which is this thing over here. We would get into the technical derivation of how we could reach towards the Poisson brackets as a consequence of defining the time evolution of different dynamical variables, but that is for another video. And uncertainty principle and commutators are very well known and very well related to each other. Commutators are actually purely mathematical quantities, and that is, they were not first devised in physics. In contradiction to Poisson brackets, which were obviously devised in physics. Commutators could be of two matrices as well, because matrices are in general non-commutative. So commutator of two matrices or two operators is basically this: the two matrices or operators multiplied in a certain order and then subtracted in the reverse order. Now, in the series of videos, we are going to discuss how Poisson brackets and commutators are going to be related to each other through Heisenberg's equations of motion and Hamilton's equations of motion, and then we are going to conclude it by discussing how, in a beautiful way, classical mechanics and quantum mechanics develop a kind of equivalence in the structure of their equations. Thank you, and please subscribe and like if you like my content. Okay.